I'm really happy that I'm here, and I'm really happy that you are here. So let's just make some meaty presentation, which will be most hardcore keynote you have ever seen. Have you ever seen .NET keynote about assembler, seeing assembly code in keynote? When? Where? I have a concurrent guy which is talking about this. Okay, so this is my book. As you see, it is quite big, and you can win it. Listen carefully. I will ask a question at the end, and you can win this signed copy of it. So listen carefully, simply. I will ask at the end. Okay, so as you said, my presentation is about ref everything, so let's just get party started. A few words about me. I wrote this book, I'm on Twitter, please follow me. I have a blog, I'm a kind of co-organizer of .NETOS things, which is an initiative of people which are talking about .NET performance, so you can look for us. Maybe we'll do also something here in Belarus. And have you ever played any card game? Magic the Gathering, Hearthstone, something like that? I'm just designing a geeky thing, a card game for .NET developers. So if you like playing card games, it will be physical card game about building up and avoiding memory leaks. So maybe you will be interested. But enough about me. Let's start the most hardcore keynote you have ever seen, maybe, probably, which will contain also assembly code, for example. Let's start from the beginning. Class versus struct. What is the difference? Can any one of you can say a few words? What is the difference? Reference, a value, contra value type. It is a main difference between the struct and the class. The class represents reference. References structs is the value itself. So, for example, let's say we have such simple experiment. We have a program which has a main method. It has a run method, and we pass helper to. We have some helper method which takes some argument, which is some type. We don't know whether it is class or struct. It is some kind of type. And we are using this type, we are accessing one field inside. And, yes, there is assembler here. When the some type is a class, the code looks like that. It doesn't make any sense maybe to explain it directly here, but the main issue is here that it is passed by reference. So no matter how big is this type, no matter how big is this class, we are just passing a reference to this object. You know that, for sure. If the some type is a struct, we are just passing a copy of this struct somehow. We can say it's a value itself, so passing struct by the as an argument makes it that we are passing the whole struct. It can be using registers or stacked, but in the it makes only the most important thing is that it really is just passing the value itself. So for a small object like that, it's okay. If we make this object bigger, things are getting worse. I mean, the class is bigger, but the code looks like exactly the same because we are passing the reference. It doesn't matter what the type is big or not. But in case of structs, as you see, the code is much bigger because now the struct is big, and the compiler, JIT compiler, says that, okay, we have to pass it as a copy, and we have to use stack to copy the whole struct. So we are seeing here copying the whole structure through the stack, simply. So it is a lot of code, and it takes a lot of time to copy this structure through the stack. So what we can do to avoid this such kind of copying, we can use refs. And as any of you have used ref any time so far, so as you see and as you used, there is something like ref, which is a passing by reference. And the code is now a little bit smaller because we are passing the reference to this structure. It doesn't matter how big the structure is, we are just passing the reference to it. So it is very nice. We are using value types, structures, but we can avoid copying by using references. And it is nice. So this kind of ref as a perimeter was in C# for many, many years, and a lot of you probably use it as you raised your hand because it was from the beginning of C#. And underneath, such by reference uses something which is called manage pointer, which is also called by ref because it is passing by ref, so it is kind of another name. But underneath it is using manage pointer, and such manage pointer has such characteristics. It's strongly typed, so it points to a specific type, like in regular pointer in C++, so maybe it's not so fancy. Manage pointer, because as we have reference, regular reference in C#, it can only point to an object. But manage pointer can point to a lot of different things, like as you see, it can point to a local variable. It can point to a method argument, object field, inside field, it is interesting, and also inside an array. It can represent an array element, so we can point through a manage pointer a specific element of an array. And as is this, it's limited when we can meet manage pointer. When it can live as a local variable, method argument, and method's return value, which is quite important. Because as we said, manage pointer can represent local variable, so it is quite time limited. I mean, local variable has a lifetime limited to the method itself. So because of that, manage pointer also has a limited lifetime. It can also live only as a local variable, method argument, and return method value, but it can't live on heap. It's critical that the manage pointer can live on the heap. It can't land on the heap, because it will be problematic. Because imagine that we have a managed pointer living on the heap with some lifetime, and it points to local variable. But this local variable probably is very limited, and it will just die after the method ends. And what should this managed pointer point to then? It's simply not possible to represent local variable on the managed pointer on the heap. So, since the C# 7.0, Microsoft is putting a lot of love into the ref because they provide possibility to write fast code because of avoiding copying, using value types, and the JIT also nicely optimizes using refs. So they are adding a lot of things related to ref, not only to ref passing by reference, as you saw. So this we know. Ref parameters. Manage pointer is used to pass parameter, to pass type as a object as a reference, and it is okay. But the story begins now, because as I said, Microsoft added a lot of things recently since the C# 7.0. So for example, we have ref locals. Have you ever used ref local? Only few people, nice. So you will learn about it. Ref local is a kind of variable which represents this is by reference. So now you can say, for example, that this this object is a reference to this argument. So maybe by itself it is not so useful, but we can also go deeper. So for example, this local reference is a reference to an integer being the field of other type. So now we can go into this integer directly, and this is just a pointer, so we are using this as a shortcut to a specific field. And accessing it will be much faster now because it is just a pointer underneath. So this is a ref local. So for example, we can use it for creating shortcuts to some deep data of the structure. So for example, if we want to dive into some field and some array inside and the specific element of this array, we can create such ref local shortcut to this specific element. So accessing it now, it will be much faster, not going through this field and through the index, but just we are getting the ref local reference to a specific field and array, for example. So this is nice, but this is kind of not the most important thing that they added. They added also possibility to return something, which was required some tuning of the specification of the IL itself, because it is not always by ref, returning by ref everything. We can't return by ref everything. For example, this code is bad. I hope it is quite clear, because we have local variable here, and we are trying to return reference to it. But it doesn't make sense because this local variable will end his life here. So returning reference to this local variable doesn't make sense because after this method ends, this reference would point to nothing. I mean, it will be very dangerous to represent such local variable by reference. So this code is bad, but this code will be okay because we are getting an array from outside of the method. So from the perspective of this method, the array lives longer than the method itself. So we can pass a reference to a specific index of this array, for example, because from the perspective of the lifetime of this array, it is okay. So we can return an element of an array by reference like that. Is it clear, at least a little? Okay, so nice. The question for you, what do you think, whether this code is bad or not? Who thinks that this code doesn't make sense and it should not compile? Okay, like 20%. Other think that it should work, and a lot of other people doesn't have an idea currently. The answer is it is working. I mean, it is interesting, but it is working because we are creating here a local variable which represents an array, and we are returning reference to a specific element of this array. But this prolongs the life of this array itself. So outside of this method, we are getting a reference to a specific element of an array, and it makes it living longer, because for now, GC will treat this as a root of this array. So it won't clean it, because we have now, from outside of this method, after this method ends, we will have this one element of the array, and it makes the GC knowing that it should not clean it, because we have the specific element. So it is interesting, and this is kind of surprising that it is working, and it required kind of tuning of the runtime itself to make it working. And this is, in fact, called interior pointer, because we are just pointing into the object, the interior of that object. So this interior pointer has to be interpreted by the GC somehow to not clean the array, which is represented by such interior pointer. Okay, so let's look at a few examples about ref returning. We have classic code without any refs currently, which is a book collection. It's a wrapper around the array of books simply. And we have method which just gets a specific book by title, searching through these books and returning the book which has this title which is specified. So, and book is currently a regular class. So we are just having this, newing up this collection, finding a specific book, and trying to change the author of this book. The result will be obviously okay, because classes are references, so we are getting a reference to a specific book from inside this collection, and the result will be that I will be changing the specific book, because it was returned by reference, as all classes are returned by reference. What is the result if we would ref return class? It would be exactly the same. We are returning reference by reference, which is kind of maybe not necessary, because we now have two references. We are returning reference to a book. So from this perspective, the result is exactly the same, and returning references to references, in fact, is in C# quite not very often seen, because it doesn't have a lot in return. But the result, what will be the result in such case when the value book is a struct? When the value book is a struct, we are returning it, but value book is a struct, so it's passed by value, so we will just returning here a copy of the structure, yes, because it is of a structure. So in this case, the result will be that the original book wasn't changed, because we are here modifying the copy of the structure from inside this collection. And we can pass it, and we can operate on the original value by ref returning it. So we can now use these ref keywords to return a book from inside the collection and assign it to a ref local book and then operate on this reference to the structure inside this collection. And now it will work because we are operating on the reference to the particular structure inside the collection. So it is good because when we have a collection of value types which have a nice, for example, memory locality, and we would like to operate on such collections, we can return specific elements and then operate on it without copying, operating on this particular element without copying, and this is nice benefit of it. Ref returning. So it was kind of from C# 7.0 added for such scenarios. So because of that, probably you will hear a lot, maybe not a lot, but more and more about ref returning collections, where you have collection which allows to ref return its elements. But for example, even indexers can ref return, but as indexers are already taken and have the already agreed semantics, we can't reuse indexers in lists or other collections. So it was agreed that method, the standard name of the method which returns by reference will be item ref. And you will have item ref which returns elements from a specific collections. And for example, all collections in system, immutable collections already implement item ref. So you can return element from immutable collections, which is nice. So this is one thing. Another thing, more advanced one for even more nerdy one people. If you have ever used ternary expression, there is ref ternary expression, even added in the newest C#. So instead of writing a regular ternary exception, you can use refs. And it allows you to write quite enigmatic, let's say, and cryptic code like here. For example, you can, of course, pass as a parameter result of ref ternary expression. Or you can assign to a result of a ref ternary expression. So the code looks quite strange like that because this assignment is on the left side and we are just assigning this text whether to this one and or this field depending on the condition. So it allows us to write it's not very popular thing, probably for people using refs a lot. Maybe it will just shorten their code, but yes, this is an example that they are just adding, constantly adding more and more things related to refs. For example, also there is ref for each. So we can iterate by reference all elements in collection if current method of enumerator ref returns something. So we can do something like that. If we have a collection and we would like to iterate through it through references, you can write for each ref something in something. It only requires that the current method of enumerator ref returns simply, which may be or may be not useful, but again, it is example. As you see, they added that in the newest version of C# currently available, C# 7.3. So currently there is no API. I'm not aware of any public library using it, but still we can expect it will be showing up in the future. But as you refs in general are write and read. I mean, we are just getting reference and we can do anything with this reference because it allows both reading and writing. So then they added also read-only semantics to have something that is only to read and not to write. And for example, also in the quite newest C# they added read-only refs, which is just a reference that is read-only. So this allows modifying. It's also very important to make sure that you understand that what is protected by writing. I mean, if it and it depends what it is represented by the by this managed pointer by the ref. If it is a reference type, so if you are using it to pass a class, the reference itself is protected, so we can't modify the reference, but the object pointed by the reference is not protected. And for value types, so for structs, the value itself, so the struct itself is protected from writing. I will show you examples soon. And this read-only semantics is available in via two keywords. For return value type, for return values, and for local variables, it is a read-only keywords, and for method parameters, it is in keyword. Maybe it was not very fortunate decision, but it is like that. So we can, if we have reference typed reference, so we ref returning book, which is a class, which is a reference. The only thing which is protected is the reference itself. So we are getting the reference to a book, and we can't change the reference. But we can change the object itself. We can change its fields and so on, because only the reference is protected, not the object itself. In case of value types, like structures, the protected thing is the structure itself. So this won't compile at all, but we can also modify the structure itself, because it is read-only book, so we can't change any fields of it, because compiler won't allow it. So it is a nice combination of things that we have something passed by reference without copying, but it is also protected from modification, which can be useful in some scenarios like that. Point3d is a struct, because we would like have it small. We have a static field, which is origin, and we would like to use it, but without copying. And because we would like to avoid copying, we would like to use ref, but we won't allow changing it, because it would be strange if someone in our code would change the meaning and the values of point3d origin. So it have to be read-only ref, to have it without copying and without chances to modify it. So it is a good example of read-only refs. And in parameter is a ref read-only parameter is like the same. So if we are passing something as a ref read-only, we can't modify the fields. As a value book is a struct, it means that we can't modify the book. We can't modify any of its fields and so on and so on. So it's like not copying things and having it passed by reference, which is nice. And in fact, we can use this in parameters everywhere. As you see, for parameters, in lambdas, in indexers, even in extension methods. So we are passing this GUID as a ref read-only parameter, so it makes that we can't modify this extension method, but we won't be able to modify the object itself. So it's just quite powerful mechanism that you can use in many places, in fact. But the question is, what happens in this code? I will give you 1 minute. Do you see any danger in this code? Sorry? Yes. You already answered the next slide, so it's absolutely you are right. The problem, the source problem here is that we have a struct which has a method which modifies the struct itself, which changes some field, and then we are trying to call it on ref read-only struct. So what compiler should do now if it's seeing that we are calling a method on a read-only reference which tries to modify this object? It should not allow it, because it should not be allowed to modify this object in any way. So what the decision was, because it turns out that detecting such a situation on the compiler side is very complex, and currently it is not detected. The only thing that we can do is to operate on the copy of this struct, in fact. So if you are calling this method here, we are just calling it on the copy of the struct. It is called defensive copy. Let's allow to call it, but it will modify some temporary copy of this struct, of this structure. So it will be quite suppressingly for some scenarios. Like, for example, so yes, this won't be allowed, and this can be problematic. We can even see in the EL code that indeed there is this copying of this structure happening. It is called defensive copy because it defends us from allowing this modification. And how to avoid that, I will say in a few slides. One side note, it is not only for refs, in fact, it's for all read-only fields. So, for example, if you write such code that is about, I don't know, updating some balance, it is not working, in fact, yes? Because we have read-only structure here, which we are trying to update here by 100, but it will update a copy of this structure, so it won't update the original structure, and the result will be 0 and 0 because this update value operates on the defensive copy. It will be also quite surprising, for example, spinlock is a struct, and if someone would like to be clever and cache it, like create static read-only spinlock, calling on this spinlock will be calling on the defensive copy of this spinlock. So you will be entering some temporary spinlock and not the original one, which makes this completely useless. So you can also find such issues on GitHub that, hey, my spinlock is not working. That's because it is read-only field, used as a read-only field. Read-only struct is just a combination of this, so you have all fields must be read-only, and you can't modify struct after creating it, so it is a kind of extension. You have all fields as read-only, and after creating such struct, you can't modify any of its field, and this is very good for read-only refs, because now JIT and compiler will know that if you are passing read-only reference, it can avoiding creating defensive copies because it won't be modified because it's read-only structure. So we can avoiding creating defensive copies. So a way of avoiding defensive copies is to create read-only structs and pass them as read-only refs, and we will be working together very nicely without creating those defensive copies. And we will see in the code that, in fact, indeed the defensive copy is being reduced. So we can pass around a lot of things by reference, but whether it is all related to ref, no, because we have something like ref struct, which is an even more fancy thing. The rationale about this is that we would like to have a type that can contain managed pointer, but managed pointer can live only on such things like local variables. Saying in opposite way, we can say that a managed pointer should not. We can say that managed pointer should not even ever live on heap. So we would like to have a type that also would live only on stack, not ever would be created on the heap. And so it would contain by reference, because by reference will have the same limitation as the type itself, and that's why it's called byref-like type. And so it is called ref struct, in fact. So it is a new kind of struct. We are adding this ref keyword introduced recently, and we are creating such ref struct, which is a regular struct, but it guarantees that it won't ever be created and it won't ever happen to live on the heap. Yeah. So we have a lot of limitations. Like it can't be a field of another object, it can be boxed, it can be a static field, it can be a field of an array, it can implement interface. In fact, it can do a lot of things just because we want to guarantee that it will be never living on the heap. And this is very nice for us because now it will be safe that such a ref struct will contain also managed pointer. So it can be a part of another ref struct, it can be used as a local variable, as a return type of by ref. but again, anything not to create it on the heap. It gives us two nice things. It never be heap allocated, so it is fast, and also it will be accessed only by one single thread, so it also doesn't require any synchronization because it is only accessed by only a single thread. It is nice. So we can also combine it, for example, create read-only ref struct, which is now obvious. It will be a ref struct which is only created once and cannot be modified. We have also something like disposable ref structs, like we have this problem here. That we would like to have a ref struct which implements iDisposable to be used by using, but ref structs cannot use and cannot implement interfaces, as we said. So the decision was quite simple. It just is done like that. If the method, if there is a dispose method inside ref struct, it is okay for C# compiler, and it can be used inside using clause. It is just enough. It doesn't need to implement iDisposable, and it will be working like that since C# 0.80. Example of that is a kind of wrapper around unmanaged memory, for example. So we are getting this in the constructor, we are getting reference to some unmanaged memory, and in dispose, we are just disposing this unmanaged memory, and we will nicely work thanks to the this dispose handling. Another thing, people would like to have this because, as we said, ref struct will create it mainly to represent something which contains also byref instance field, byref managed pointer, and this is exactly why span was created. We would like to create a type which can represent subregions of other objects. So we need, for example, subregion of array without copying it. So we need to have managed pointer which points inside such array with a given length, saying that this is a slice of an array. So we need to have this managed pointer inside such span, and this is exactly like what we would like to have. Span should contain managed pointer which points inside an array, and the length saying how many array elements we represent. So we would like to imagine span as such type. It is a struct which contains byref, which contains a reference type pointer. It doesn't compile, it does not support it in C# currently, such code, because it just doesn't written like that. With C# compiler doesn't support such kind of writing, the ref keyword inside the field, but it was, like said, omitted by using by reference type, which is a generic which represents such ref field. So it is a field representing managed pointer. This by reference, in fact, is a simple wrapper around the simple pointer, and it is appropriately represented by runtime inside. So in the end, span looks like that. It's a length to represent how many elements we represent, and also this managed pointer represented by this magic by reference type, which says from which memory region, from which memory array element we start, and so on and so on. One would like to ask, okay, if we had something like by reference here, I would like to reuse it in my types, because currently it is internal and you cannot reuse it. And one would ask why I would like to use it. But in general, interpreting such managed pointer as a reference, as a field of another type is quite expensive. And also we would be able to create some quite cryptic graph references when one object field points to inside other object field, and then this field points another field, and now the object graph between objects would be very, very complex. So in general, it is quite, on the one hand, it is very complex in interpreting, and on the other hand, it is also very complex and introduces quite big overhead to the GC itself. So we should rather not expect that it will be exposed to us, and we would not be able to use it as a general thing. So as a summary, a lot of refs You have ref in parameters, so you have ref locals, ref returns, ref ternary expression, a lot of refs in different ways, ref structs. I hope that you currently have a little bit more knowledge about what is possible by using all these ref things. And as an ultimate example, I created, I hope it will be just a few slides, value string builder, which is a ref struct, as you see, because I would like to implement an alternative implementation of string builder, which is a set type because it is class, it creates, it allocates. I hate allocating things. So we should create something which is as fast as possible, and we are creating ref struct value string builder, which is nice because it will be created on the stack or in registers. It won't use any memory. We are providing it some external buffer. I will explain soon why. It also ref returns also, the indexer ref returns the specific chars, and appending is simple operating on the internal buffer provided from external code, filling the successive characters by the thing that we provided. So it is, from the algorithm point of view, it is very simple, but what's more important, it is ref struct. It will be accessed only from a single thread, so we don't have to care about synchronization. And yes, so we have getting this. We are getting this span, which represents some kind of initial buffer, and then, of course, this initial buffer can fill if we will be appending a lot of characters. So at this point, I'm using, if it will happen, I'm using another fancy thing, which is array pool. So I'm changing this internal buffer with an array pool, which is with an array which is shared from array pool, in case if the initial buffer is filled. But this is just handling the case when the initial buffer was filled. It has also dispose, so it can be used with the using clause, which just returns the array if it was rented. And the most sad method is to string, because it needs to allocate. I mean, at some point we need string probably, so we need to create a new string probably for our code. Expects string, so we have to create this string at the end. And using it is very nice because it is exactly like the regular string builder, but now we are operating mostly on the stack or registers. I'm creating a very small buffer on the stack with the help of stack alloc keyword, so I'm not touching any heap here. There is no GC pressure here because everything happens on the stack, or maybe even on the registers because JIT is able to optimize it. And I'm appending some things, and in the end, I'm creating the resulting string because I need the string. And that's why value string builder expects buffer from outside, because I would like to be able to create stack alloc and pass it inside the value string builder. The difference in the performance is maybe not, let's say, kicking us our asses, but still it is noticeable. I mean, it is faster, and it is also allocating a lot of less memory because of this, that in fact these bytes are only the resulting string and not inside the string buffer there is nothing allocated. So maybe if this is happening once per day, this makes any sense to make such type, but if it is happening 1,000 per second, obviously this difference in allocations will be huge for your application. And to be even more fancy, we can also create such enumerator, which ref returns by ref. So the current will ref return. And then it allow us to make such funny things like in place modifying the string and the buffer itself. We can for each now for the particular characters in this builder and create a character in place, modify it by increasing ASCII code by 1, for example. It's just a dummy example, but it shows that it makes such things possible. Okay, and that's all. Now I have a question for you regarding regarding winning these 2 kilograms. What is the name of the pointer which is pointing inside other objects? interior pointer. You were the fastest. So I don't know if speakers should attend, but this contents. But I didn't say anything about that. So congratulations. Do we have time for questions?
Thank you.
Thank you.
Yeah, we have a couple minutes, probably almost 5 minutes for your questions. Hand here. Do we have a microphone? Thank you, by the way. It was very interesting. I didn't know about disposable.
About which one?
That you can dispose ref structs.
Ah, yeah.
Konrad, thanks for the overview. So what I would like to ask is basically...
I'm not sure if it's working.
Basically, we understand that the main point of introducing ref is performance optimization.
Yep.
On the other hand, I can say that like 99% of the enterprise applications we are writing is not implementing any in-memory databases. They are just communicating with some kind of storage, like, I don't know, database, search engine, external services. And the performance hit is introduced by those external calls, you know?
Yep.
Unless there are significant design flows, the memory management doesn't introduce much overhead because the objects are small, okay? On the other hand, I can see different areas where performance is critical and the requirements operate in terms of microseconds, some like a couple of milliseconds, for example, electronic trade, and they are not using .NET for like obvious reasons. So can you elaborate what kind of applications might benefit from these refs?
Yes, yes, for sure 90% of applications doesn't require it, and I would not start designing domain by using references or something like that. On the other hand, I see the more and more adoption of .NET Core in such scenarios as you said, because Microsoft is putting a lot of love to the performance. They are blogging a lot of things about that they are able to process millions of requests per second and so on. So a lot of companies also are also like starting to interest in .NET Core also as a high performance platform. And in such scenarios, this is an answer for such people, yes? So I'm seeing companies that trying to use it in big data when maybe you have a single operation is not so important, but you have so many objects that every millisecond counts, for example, yes, gaming, other things. So yes, there is no specific domain and company that I could point to that is starting to using refs and all this stuff, but I'm seeing a higher and higher adoption of this as a high performance platform, which is nice simply because it now provides such capabilities. And I'm very happy with that.
Thank you.
Thank you.
Just small question about array pool. Can we use it everywhere? Can it be by default thing as a backend for array allocation? Or we have some constraints of using array pools sense?
I would not probably create any array through array pool because it create some overhead by finding a good array inside an array pool. So creating each array, small arrays through array pool would be probably quite big, would introduce overhead. But the more bigger arrays you create, I would use array pool. If you are using, the more big arrays you use, the more you should be interested in using array pool. And especially if you're creating so big array pools that they land in large object heap, so bigger than 80,000 elements or so, for sure you should by default start using array pool. The bigger array, the more sensible is to use it simply. But not for very often created small arrays. But it will be overhead simply, not giving a lot in return.
Any more questions? Okay, I have a question. So, have you heard about readonly methods?
About what?
Read-only methods.
Yes, yes. There is an ongoing project of read-only methods because, as you said, you can mark the whole struct as read-only, but it puts a quite big limitation because maybe not the whole struct makes sense to read-only because it blocks for modifying it. And there will be a probably feature which will allow you to mark only a single method as a read-only. And then the JIT will know that this particular method is read-only and we won't modify this structure, so I can avoid creating defensive copy.
Thank you very much.
Thank you very much.